In this lecture we can see about the routing concept in networks. So routing plays a main role in transferring the data packet from one place to another. Also here we concentrate on finding the least cost routing. So first of all we can learn about what is the importance with unicast routing. So unicast routing, when a packet is moved from one sender to another receiver, based on the distance of separation between the sender and the receiver, the packet has to go through different nodes in the network. It has to cross different routers. It has to cross different LANs. So how the route will be followed is based on a forwarding table, and with the entries available in the table which will be getting updated, the data packet can able to move and the router can able to decide the next link for the data packet has to go. So here the routing protocol also taking a main role, and certain procedures we need to follow, and this simple approach will enable the data packet to reach the destination from the source or from the sender. And routing a packet from the source to the destination means routing the packet from the source router to the destination router. So these were the things which we need to consider as unicast routing. Now in unicast routing we also have to know about least cost routing. So least cost routing takes a main part, that is how we can able to find the shortest path. So every router will be having a routing table. The routing table will be shared among the available nodes in the network, and every individual node will be updating its own table after getting the information from the neighboring node. And this approach we can able to say as or we can consider as a weighted graph. So when an internet is modeled as a weighted graph, we can able to assign or we can able to interpret the best route from the source router to the destination. So here we have a best route between A and E that takes the path from A to B and B to E, and overall the cost will be 6. That means every data packet moving through these routers has to take on this least cost route between this A and E towards the destination. So now when we consider this diagram, here we have this is called a weighted graph. So for this network we can able to simply have a weighted graph by denoting these are the nodes. So at first we have the routers. The routers are actually been assigned as a node, and we are giving a weightage name also. So A, B, C, D, E, F and G, and for every link we are having the weightage. We say this is the cost value between this A and B, and this is the cost between A and C, so A to B and B to C. So likewise here for every data packet to move from, which when we want to consider the shortest path between this A and this E, then there are two possibility. So two paths are available. One is A to B and B to E. One is A to D and D to E. And when we consider these two, we can say that the path from A to B, so the link A to B and B to E, takes a total cost of 6, which will be less when comparable to this A and D to E. So here the cost will come as 8. So 8 will be more when compared to 6. Therefore we say that with this least cost we can able to route the data packet from this router A to this E. Likewise here every node means every routers will be in link with another router, and we have the weight values, that is the cost values. Therefore, now we can say that a least cost tree is a tree with the source router as the root that spans the whole graph, and in which the path between the root and any other node is the shortest. So like in the previous example, so the path between A to E is actually formed as the least cost from A to B and B to E. So here we can say that the source router will be A. So likewise, n number of least cost trees can be formed from a weighted graph. So weighted graph means the graph we draw, the diagrams, the schematic approach we draw from the network diagram. So here 7 possible least cost trees are available for this. For the same diagram where A to B, C, D, E and F, G. So here how we are forming the least cost. So that makes the point. So when we consider this A as a root, that means the source root. So from A to the remaining all nodes in the network in this weighted graph, we have to form the shortest route, that is based on the least cost. So for example, if you want to pass a data from this A to F, so which will be the path we need to assign, that is A to B, B to E and E to F. Therefore the total cost will be, for A to B the cost is 2. To make the data transfer from B to E the cost is 6. So 2 plus 6 comes here 8. So in this way we can able to form different root nodes. So here B is the source root, here C is the source root, here the root node is D, E, F and G. So for example, if we say that the route from A to F in A's tree is A to B and B to E and E to F, but the route from F to A in F's tree is F to E, E to B and B to A, which is the inverse of the first route, and thereby we can able to assign the cost value. So this cost value is called the least cost value. So here in this kind of routing we will be following the least cost based on the availability from the network, which we consider the shortest path between the source and the destination. Therefore we say that this routing approach takes more importance in delivering the data packets from one source to one destination in network. That's all in the class today.